Welcome back to The Hidden Layer, where we decode the world of AI. Today, we're doing something a little different. We're going to tear down Anthropic's Claude Code, basically reverse engineer it to give you a real, practical blueprint for building AI agents that you can actually trust. Oh, and you're going to want to stick around, because I've got a secret finding from Anthropic's own research that will completely change the way you think about AI assistants. So, let's jump right in.
Okay, let's start with a number that's just wild. 1.6%. What is that? Well, in a state-of-the-art AI coding agent, that's how much of the code is actually the AI model. You know, the brain. And no, that is not a typo. Just 1.6%. And this one tiny number? It completely blows up the biggest misconception in AI today. See, we all think that building trustworthy agents is all about a smarter model, right? Nope. It's about the system you build around it. Because what about the other 98.4%? That, my friends, is what developers call the operational harness. Think of it as all the infrastructure for safety, reliability, and control. It's the protective shell that keeps both you and your system safe from the raw, kind of unpredictable power of the language model itself. And this, right here, is what we're calling the 98% problem. The real engineering work, the part that separates a cool demo from a tool you can actually depend on, it isn't in the model, it's in the harness. And that is the secret to building AI agents you can truly trust in a production environment.
So how in the world did Anthropic solve this 98% problem? Well, their solution didn't start with code. It actually started with a philosophy: keep humans in control. It's a simple idea, but it's incredibly powerful, and it shapes every single piece of Claude Code's architecture.
These 5 values are really the foundation of the whole thing. Human decision authority means you're in charge. Safety and security, well, they're non-negotiable. Reliable execution means the agent does what you actually want it to do. Capability amplification is all about making you more powerful, and contextual adaptability lets the system learn as it goes. But, how do these high-level values actually turn into real code?
Well, this is how. You take an abstract value, like safety, and you turn it into a simple, powerful rule: deny first with human escalation. What that means is the system's default answer is always no. So safety isn't an afterthought you bolt on later, it is built in from the very beginning. So this philosophy, it leads directly to a very specific architecture. And honestly, the best way to think about it is like an operating system. The LLM is like the kernel, super powerful but raw. And the harness, that's the OS that manages it all, keeping it safe, stable, and actually useful. Let's just trace how this thing actually works. You give it a prompt, right? The model then suggests an action, maybe something like editing a file. But before anything happens, the permission system steps in and reviews it for safety. Only after it gets the green light does the action get executed by the tools. It's a really simple but incredibly powerful control loop. And this brings us right to the core concept, the harness. If you remember one phrase from this whole thing, make it this one: the model reasons, the harness executes. This strict separation is the absolute key to safety. It makes sure that no matter what the model hallucinates or suggests, it literally can't bypass the hard-coded rules of the system. Okay, so what does this all mean for you, the developer watching this? Here's a practical, actionable playbook for building your own verifiable AI agents based directly on the lessons we've learned from Claude Code.
First up, and look, this one is non-negotiable. You have to separate the AI's reasoning from the system's execution. Never ever let the LLM's output directly trigger real-world actions. This creates a critical buffer, a space where you can add checks and logs and balances, and that's what makes your whole system verifiable.
Second, you have to watch out for something called approval fatigue. The data shows that when users are constantly bombarded with approval pop-ups, they just start clicking yes about 93% of the time, which makes the whole check useless. So what's the solution? A graduated trust system. It gives the agent autonomy for low-risk stuff and only bugs you for the high-stakes decisions. And third, you have to obsessively manage the context window. It's the AI's short-term memory, and it's your biggest constraint, full stop. Claude Code, for example, uses a 5-layer compaction pipeline to manage this. You just have to be incredibly strategic about what information you're feeding the model to keep it focused and effective.
And that brings me to that secret I promised you at the beginning. We've just spent all this time talking about how these tools can amplify our abilities, but there's a hidden cost. Anthropic's own research uncovered something pretty surprising, and to be honest, a little concerning about all this powerful AI assistance.
They call it the paradox of supervision. The idea is, the better the AI gets, the more we lean on it. And the more we lean on it, the more we risk losing the very skills we need to supervise it properly. We kind of go from being the pilot to just being a passenger. So just how bad is it?
This is the slide that changes everything. In a study, developers who were using AI assistants scored a shocking 17% lower on code comprehension tests. Yeah, lower. The AI helped them write code faster, for sure, but it critically damaged their understanding of what they were writing. This is the paradox in action, and it has really serious implications for the future of our skills. So we're left with this huge question. How do we build AI that makes us smarter, not just faster? That is the real challenge for the next generation of AI development. Claude Code gives us a blueprint for safety, absolutely, but now we have to start designing for wisdom. What do you think? Let me know down in the comments and let's talk about it.